All right, so functions are rules that give us outputs when we simply supply them with inputs. Very often we want to know how fast the outputs are changing compared to a change in the input values. This is referred to as the average rate of change. So Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are going in the race in feet is given below with Max's distance given by the function m of t and Evie's distance given by the function e of t. So how do you interpret the fact that m of 12 equals 30? So let's look at m of t. That's this graph. We're going to look at the red graph because I'm using it. So m of 12 equals 30. Remember that the number inside the parenthesis is always your x. So m of 12, you'll notice that it goes up by, so 12, 14, 16, 18, 20. It goes up by 2's on the t, the second, so it goes up by 2 seconds. So m of 12 is going to be here, and of 30. So this is m of 12 equals 30. So that means that at 12 seconds, Max is 30 feet away. And then if both runners start at t equals 0, how much of a head start does Max give his little sister? So let's look at Max's little sister here. She starts at, so it looks like that's going up by 5s. She starts 25 feet away because at 0 seconds, so on the y-axis, she is starting at 25. Does Max catch up to his sister? How can you tell? If you look, Max is going up 5 over 2, up 5 over 2. I should use red. Up 5 over 2, up 5 over 2, up 5 over 2, up 5 over 2. But then you look at Evie, and it looks like she's going a whole lot slower. If she was going up 5 over 2, it would look like this, but she's not. Instead, she is going up, let's find another place that it crosses. Looks like I don't find one exactly. But you'll see that Max is going to eventually keep going up 5, up 5, up 5, and he will eventually meet up with her. He will catch her. So yes, his rate of change is higher. All right, so we have already answered these ones. So how far does Max run during the 20-second race? So in the 20-second race, if that's really where we're stopping, that Max ends up running 50 feet because he ends right here. How far does Evie run? Evie goes from 25 to 60. So 60 minus 25 is 35 feet. Which obviously this is the calculation used. So how fast do both Evie and Max travel? In other words, how many feet do each of them run per second? So Max's feet per second, if we take 50 divided by 20, his feet per second is, so we divide 50 because that's how far he ran, that's feet over seconds. So 50 divided by 20 is 2.5 feet per second. Now, Now we're going to look at Evie's. She ran 35 feet in 20 seconds. So we divide 35 by 20, and she ran 1.75 feet per second. In the first exercise, we were calculating the rate that the function's output, or y values, were changing compared to the function's input, or x values. This is known as finding the average rate of change. You might think you've seen this before, and you have. Finding the average rate of change is the same as finding the slope of a line. There is, of course, the formula for finding average rate of change. So the formula is here. So it is change in y over change in x. So consider this function for exercise 3. Find its average rate of change. So from x minus 1 to x equals 3. So what you're going to have to do is you're going to have to find f of negative 1 and f of 3 to be able to find what y equals in each one of those. So f of negative 1 is going to be negative 1 squared plus 3, which is 1 plus 3, which is 4. And f of 3 is going to be 3 squared plus 3, which is 9 plus 3, which is 12. So we're going to first find f of b minus f of a. So f of b is our second one. So f of b is 12 minus, and f of a is 4. That will be divided by b minus a. Well, b minus a. So this becomes 12 minus 4 is 8, divided by 4 is 2 for the average rate of change. So we're going to look at the next one. Function h of x is given in the table below. Which of the following gives its average rate of change? So they give you the interval, so we're looking from just 2 to 6. So from 2 to 6. So we're ignoring the 0 and 10. We're just looking from 6 to 2. So change in y over change in x. So let's look at the y, or the h of x. From 3 to 9, what happened? It went up 6, so positive 6. And then we look from 6 to 2, this went down 4. So 6 over negative 4 is what we are reducing now. 6 over negative 4 becomes negative 3 over 2. So number 1 is the average rate of change. Exercise 5. Frances is selling glasses of lemonade. The function g of t models the number of glasses she has sold after t hours. What is the average rate at which she's selling lemonade? So first we need to find g of 2, and then we need to find g of 6. So g of 2 is going to be 2 squared plus 4 divided by 2, and g of 6 is going to be 6 squared plus 4 over 2. So 2 squared is 4. 4 plus 4 is 8. 8 divided by 2 is 4. 6 squared is 36. 36 plus 4 is 40. 40 divided by 2 is 20. So now we need to find our average rate of change. So from 20 to 4, because that's our change in y, 20 to 4 is negative 16. So negative 16 is our change in y. Then from 6 to 2, you go down 4. So change in x is going down 4. Then we just look at negative 16 over negative 4 becomes positive 4. And now we need to include proper units. So it is 4 lemonades per an hour.